Alright, hello again. Here is Chapter 7, IP addressing. We're now going to actually talk about how we make use of IP protocols work. IP version 4 to start with, and IP version 6 a little later on. So let's get in here. So IP addressing is literally just a bunch of ones and zeros. But they're set in ways so we can understand and read them. So this is what the computer sees, all these ones. Which is a lot for us to comprehend. It's not very easy for us. This is what we turn into. We take them 8 by 8. Sorry, octets. We put them in octets 4 times. So it's 4 ones. So we get this dotted decimal address we're talking about, or also known as the 32-bit address. Because it's got 32 ones and zeros. Ones or zero. Give this little video a watch because it kind of helps. Positional notation. Fun part. The value of, you are used to the binary system. You have the ones column, the tens column, the 100s column, 1000 columns. This is not that system. So if you were to put in here, this is what the number is: 1, 2, 3, 4. You have 1 1000. You have two 100s, 3 tens, and 4 ones, which gets you 1234. So binary, it's different. It's 1, 2, 4, 8, 16, 32, 64, 128. Doubles after that. Doubles every step of the way. So you can get just the same numbers, but it takes longer to write out. So you have 1, 1, 0, 0, 0, 0, 0, 0. So you have 1, 128. You have 164, and you have no of the others. Together you get 192. So I have some worksheets you guys asked, some of you emailed me about. I'll be using them. So this is how we do it. We take the binary parts one by one, and we go through and do this adding to come up with our dotted decimal notation. And this is what you see. You'll need to be able to convert back and forth. So in this case, we have 1, 1, 0, 0, 0, 0, 1, 1. So it's 192, 194, 195. Yay! And you can get new numbers. Try them out. Good practice. Positional value is what they're talking about. That's how you do it. The number you're looking for, subtract each positional value. Put one in there, subtract it down, and go on. So if you have 192, you subtract 128, and you get 64 left over. So you subtract 64 from 64, you get 1 again, and then you have 0, so everything else is 0 along the line there. Again, there's a much better example right there. 1 step at a time is greater than 8, so on and so forth. This is how you get your numbers. Works out pretty well. Again, reverse order. Subtract 128. Yes, so it leaves us with, well, it's not 64. I have used paper. I'm not that good at math. Not my favorite thing to do. Here's a little game that makes it funner. I've tried it. It's okay. It's okay. It's fun. It's a good way to do it a few times. It isn't just repetitive math. Now, the IP address is broken into 2 parts: network partition and a host partition. We'll explain how you tell the difference in a little bit here. But this is network partition. This is the broke off for the host partition. Subnet mask is what tells you what the breakoff is. In this case, your subnet mask is this: 255.255.255.0. Wherever you have a 1, that's network. Where you have a 0, that's host. Simple enough. So then you have to break it down into binary. Oh, that's horrible. Now we have something called ANDing. Break down what you got into binary. Break down your subnet mask into binary. Then 1 and 1 equals 1. Anything else is a 0. This is where you end up with your network address. It's a good way to double check. There is something called, there is a shortcut I posted in the files that you can look at. It's got a nice little chart and table that does this all for you because there's a finite number on the numbers. Again, this is good practice to try. Do a couple before you move on. I really suggest you do a couple before you move on. Again, you have 2 ways well, 3 ways of displaying it. Sub the mask, 255, and some breakdowns of the 128, 192, 224, 240, 248, 252. These are the only numbers you're going to see. You can also break it into binary, but you can also do what's called prefix length. It's a lot shorter than these other ones. All it is the count of number of zeros we have. 8 zeros, 8. That's the count of ones we have. 8 ones, 8. 16 ones, 8 twice, 16. 3 times, 24. Now we got 1 more, 2 more, 3, 4, and so on down the line. A little practice will make sense. Now, we break this down. We have these ranges, addresses. What you get is this is a network address. Notice the 0 there. This is the address for the network. We don't have that host portion put in. Remember back earlier where we had the breakout between host and network, the network and host. It's just the network part. Now with the host, you have starting 1 past network address, the first host address. And then you continue down until you have everything but 1. So you always have this 1 short. If you have all 1s in that host portion for the network, you have a broadcast address. So the last address is 1 short of that. Every time. For example, host portion. This is the host portion, this is the network portion. This is the network portion right here. 10.1.1, 10.1.1, 10.1.1. The point. Host address is this part here. This 10, this 11, this 12, this 255, this 1. In this case. So the first host address is .1, which is typically a router or a switch. Typically a router. The last one is usually some type of PC if you have to go that high. This is 255. Then broadcast is 254. Sorry, 254. Broadcast is 255, where you have all 1s there, which will go to everything on that network. So everything that corresponds to that network portion will get that. So I need to know it. Make sure you don't use that one. Again, it's another little video to help you explain it a little bit, which would be nice. A lab to try to use the Windows calculator. It's a good thing to give it a try because, well, Windows calculator will be able to you with just about everything. And another try. Don't have to turn these in, but I suggest you do them unless you feel confident doing the worksheets. Keep going. Static assignments. Why do we need to know this? Because sometimes we need to put this into your PC. This is an example of a PC interface being entered. IP address, so the mask and the default gateway. The gateway to your router. The door out. You can also do dynamically, which means it's assigned by the system. But you need to configure the system correctly, otherwise you'll get messed up. And I've seen that, and it goes very, very bad. Unicast, 1 to 1. Broadcast, 1 to everybody else. Not back, but 1 to everybody else. Then multicast, 1 to many different things. This is where the fun part goes. So, example, source, destination goes there. Yay! And it goes to a specific IP address. Broadcast, 255. Everything is 255. Well, yeah, everything's 255 for this example. It should be the last in that network group. Multicast, source, and they have a tag and they're telling you which ones you're going for. Yeah. It puts in these 224 range. You kind of put this tag on there. It kind of breaks what you've been taught. I'm sorry. But it's important to know because it does happen. And these ranges are multicast. So they'll add this IP address to multicast and it'll assign them to devices or whatever. I know it's probably the more confusing part here, but just know this is what it does. Don't really try to figure out how it works. There's not really any questions on that. Just asking you what is multicast. You need to know it, that's what I have to tell you. But it's great. What's this? Destination IP address, yeah. Once you do click on, what is it going to go to? What device is it going to go to? Which in this case will be everybody. Right? Oh, yep, everything. It's a broadcast. It goes to everything. So you get that. Give it a try a couple times. Packet tracer, again, you don't have to do that. And I'm going to leave it off here. And we're going to finish up. We make these smaller videos because this is a thing we need to take step by step.